Hello everyone, this is our video number 2 on exam style questions. This is your video number 2 on topics moments, impulse and impact force. In the video number 1 we have already solved 3 questions which we called question number 1, 2 and 3. In this video we'll be taking up question number 4, 5 and 6. These are all your questions from the past paper on these topics of moment, impact, force and impulse. So let us start with this question number 4. The question starts from this point A. State 2 conditions necessary for a system of forces acting on a body to be in equilibrium. Now this is a question you should understand. It gets repeated again and again. So you should familiarize yourself how to write the answer here. So if a system is in equilibrium, the 2 conditions that must be happening for sure is that you should be very well versed. So what should be the answer? No resultant force and no resultant moment, right? No resultant moment. You should be very comfortable. If you see, this is a question which repeats many times, right? It has repeated in the past many times, so you should be comfortable talking about the 2 conditions necessary for the system to be in equilibrium. Now let us come to the part B. It shows a loaded wheelbarrow. You are given a wheelbarrow held in equilibrium by a gardener. The wheel of the wheelbarrow is in contact with the ground. At what point? The point name is also given at point C. There are 3 vertical forces applied on the wheelbarrow. If you see, 3 arrows means 3 forces. They are saying force number 1, which is P, is the upward force applied by the gardener. Force number 2 is your Q, is the upward force of the ground on the wheel at point C. Force number 3 is your W. W is the weight of the wheelbarrow and its content. So the 3 forces are given to you. Read the explanation to understand what kind of forces they are, right? So explain why the force P is less than the force W. Why the force P is less than force W. So the key point in solving this question is where? Here. If you can identify this term here. What is this? Equilibrium. That means nothing is in movement. The gardener is holding this wheelbarrow and all the system is in equilibrium. What are the 2 necessary conditions for a body to be in equilibrium? No resultant force, first point. So we'll be using the first point because they are saying by considering the forces you have to prove that the force P is less than the force W. So we take up the first point here, no resultant force. No resultant force means all the forces are balanced. When would all the forces be balanced? When all the upward forces P and Q, right? All the upward forces are balanced by the downward force. So W is equal to P plus Q. When you write this equation, automatically what does it prove? That P has to be smaller than W. So 1 mark you'll gain when you write down this equation, right? Another point is gained when you say so therefore P is less than W. Alright, so this is coming from your first condition which is necessary for a body to be in equilibrium. If we come to the next part of the question, I am here at the top on this side. So focus here. So you have to explain why force P is less than W. At the bottom, follow my pointer. Why force P is less than W? By considering the moment of the force P and Q about the point C. Now you have to talk in terms of moments. System is in equilibrium. Alright, so no resultant force. The first necessary condition was used to answer the first part of B. To answer the second part of B, you will use the next condition. No resultant moment means clockwise moment should be equal to the anti-clockwise moment. About what? About point C. P, if you see, it is creating a clockwise moment about C. C is your pivot. This is your pivot. This is your point C. And W is creating a anti-clockwise moment. When it is a no resultant moment, then that means both the moments should be equal in size. So P multiplied by its distance from the pivot, let us call it D1, should be equal to W multiplied by D2. And if you look carefully, D1 is bigger in size as compared to D2. P is at a greater distance as compared to W, which is at a lesser distance from the pivot. So if D1 is greater than D2, this implies that P has to be less than W. So what do you understand? A smaller force has to be applied at a greater distance to keep the moments balanced. Why? Because the bigger force is applied at a smaller distance. This is your basic understanding from the moments. Let us come to the question number C. The figure here shows a kitchen cupboard resting on a support attached to a wall by a screw. So there is a screw. Where is the kitchen cabinet? This is your wall. Try to understand the question. This is your wall. This is your kitchen cupboard. The weight of the cupboard and its content is also given. 75 newtons is the weight. And what is G? G is the position of the center of mass of the cupboard. So you are given the description about G, which is the center of the mass. The clockwise and the anti-clockwise moment about point P are equal. Calculate the force exerted by the screw. Okay, about point P. So where is the pivot? Identify the pivot first. Your first step should be to identify the pivot. If you can identify the pivot, around the pivot the movement or the rotation happens. So the first thing that you should always do is to find the pivot. If you have found the pivot, you can find the turning around the pivot, right? Turning around pivot due to the various forces that you see in the picture. So this is the point P, which is your pivot. So how is the turning happening? By the forces that you see in the picture. Where are the forces? There is a force F that you see marked on the picture. There is a force of 75 newtons that you see marked on the picture very clearly. Let us draw some curved arrows to show clockwise and anti-clockwise moment. So the moment or the turning that will be created by the force F would be like this, around the pivot. So the curving should happen around the pivot. This is your pivot. The curving should happen around the pivot. If you see, curving is happening around the pivot. Similarly, how is your anti-clockwise moment? Let me use a different color pen. How is a clockwise moment? Like this. Again, around the pivot. Pivot has to be inside both the turnings. Force F is turning anti-clockwise, the red arrow is anti-clockwise, and the force 75 newtons is turning clockwise around the pivot. Pivot is inside both the turnings, right? Because P is the pivot. Pivot has to be inside. Calculate the force exerted by the screw. So all you have to do, it is a 3-mark question. Please be careful. if you just straight away do all your working on your calculator and type in the answer, you might lose all the 3 marks if your working is wrong. But if you are showing your steps one by one, even if your final answer is wrong, you'll still manage to score some marks out of 3. You'll not be losing all the 3 marks. 3 is a good quantity, big number, right? Right? So how do we start? We say, you can say that because the object is in equilibrium, therefore the clockwise moment will be equal to anti-clockwise moment. So you can say clockwise moment is equal to anti-clockwise moment. Alright, so how much is the clockwise moment? The blue arrow is your clockwise moment. So how do you work it out? It is 75 newtons multiplied by its distance from the pivot, which is given to you as 0.24. So here in the diagram it is given to you where I am putting a tick. So where is it? Let me show you clearly. 75 newtons is at a distance of 0.24 meters. 0.24. Now what is the clockwise moment? It is the force F multiplied by its distance, which is 0.75 newtons, 0.75 meters from the pivot. So F multiplied by 0.75. When you'll solve this equation, you'll find the value of F, which will come out to be 24 newtons. That's why writing the steps are very important. Step 1, step 2, step 3. Why? Because even if you by mistake find the end result to be wrong, if your steps are correct, you'll still manage to get 2 out of 3. Writing the steps again and again, I keep saying, is very, very important in your exams. Let us come to question number 3. Sorry, it's not 3. Question number 5. Let us come to question number 5. So the figure here shows a uniform rectangular slab of concrete ABCD standing upright on the ground. The slab has a height is given 0.6 meters, the width is given 0.3 meters, and the mass is given, which is 18 kgs. So let us write down the data on the diagram. It helps us remember the numbers. You need not read the paragraph again and again. A force of 40 newtons act horizontally to the left. Calculate the weight of the concrete slab. What is the weight? The formula for the weight is mg, right? The value of g is 9.8 meters per second square, or for simplicity's sake, you can also take it as meters per second, 10 meters per second square. So for simplifying the calculation, I am taking 10. If you are working with calculator, you can use 9.8, right? So 18 times 18 is the mass times g, which is 10. So what is the weight? The unit for weight is newtons. Why? Because weight is a force. If you do not understand that weight is a force, go through my video on weight and mass to understand what is weight and why its unit is newtons. Alright. Next thing, the thickness of the slab is also given to you now. A new data has come. The thickness of the slab. So slab is something like this, right? Like this. The thickness of the slab is also given to you. What is this? 0.04 meters. Calculate the pressure exerted by the slab on the ground. What is the formula for the pressure? Pressure is force over area. What is the area? What is the force? Let us talk about the force first. Force is your weight. weight which is acting downwards, right? So it is 180 newtons. How much is the area? This is done. How much is the area? Area down here would be something like this. It would be a square, sorry, it would be a rectangle. So which would be 0.3 times 0.04. So you'll get your area as well. You'll find your area, input the values in the formula, and you'll get the value of the pressure. The pressure would be somewhere around 15000 pascals. This is a simple and an easy question, basic question that you all have been doing in your science for many years. So let us come to the part B. On the figure, draw and label an arrow to show that the weight W of the slab acting at its center of mass. This is a 1 mark, very tiny question. So many times students tend to skip such tiny questions. Students do skip, they do not read that there is a tiny question lying in between in this small space. So pay attention, be careful in the examination. We have already marked W. If you see, we have already marked the weight W. So B, the first part is done. Let us come to B, the second part. Calculate the moment of the force 40 newtons about the point D. 40 newtons about the point D. What is the formula for the moment? Force times the distance, perpendicular distance of the force from the pivot, right? Force is 40, and how much is its perpendicular distance? How much is the perpendicular distance from point D? So if I am talking about this force, how much is its perpendicular distance from the point D? Perpendicular distance. So for that you need to extend, you need to stretch the force. You need to stretch the force somewhat like this, as dotted lines, right? When you stretch the force, it is allowed to stretch the force as a rough work in dotted lines. You'll see that the perpendicular distance is also given to you in the question. This is 90 degrees. They are asking you from the point D. Perpendicular distance of this force 40 newtons from the point D is already given to you, which is 0.6. Multiply both these numbers, you'll get your answer. The moment is 6 4s are 24 and 0. This is your moment, and the unit for moment is Newton meters. So this is your answer, 24 Newton meter. Similarly, the moment of W about the point D. You can pause the screen for a moment if you want, solve this, come back and see the working. It is always a good idea when I'm talking about examination type questions. You can pause the screen, look at the question, try to solve it yourself, play the video again and see if your answers are tallying, right? Moment of W. So this is your W about again the point D. Point D. So you have to find the perpendicular distance. Again, you'll extend the force as a dotted line. Extend it as a dotted line. So far it is a solid line. Let me make it a dotted line. Where is the perpendicular distance? This is your perpendicular distance. How much is its measure? The perpendicular distance is 0.3 over D. Multiplied by the force W. W you have already calculated, 180. So this is the value of your moment about the point D. It will come out to be 27 Newton meters. 27 Newton meter. Fine so far? Any doubts? You can type in the comment box and let me know. Now the last part of the question, the ground is rough so the slab does not slide. So this force is pushing from here, but because of the roughness of the ground, the slab is not sliding. The ground here is rough, right? The ground down here is rough. The slab is not sliding. State and explain what happens to the slab as the horizontal force W is gradually increased. If the force W is gradually increased. Sorry, if the force at B is gradually increased. My mistake, I read it wrong. They are saying that the force here is, this force is gradually increasing. They are increasing it from 40 to 50 to 60 to 70 newtons. So when this force is getting increased, I am talking about in this part of the question. If the force is increasing 50, 60, 70, 80, 90, what happens? A moment is also increasing. Let us take the pivot. Around which point the turning will happen? The turning will happen around the point D. That's why we were calculating all the moments around point D. So as this force 40 is getting increased, the anti-clockwise moment is increasing. Whereas the clockwise moment due to the weight, is the same because the weight will not increase. Anti-clockwise moment is increasing as compared to the clockwise moment, and ultimately the slab will topple and rotate. So please be careful. It is a 2-mark question. You have to give 2 points in your answer to explain to get both the 2 points. What do you say? You say that the anti-clockwise moment will gradually increase or will ultimately become greater, than clockwise moment. So please in your answers write it in full terms. You will not say A, C, W, you will say anti-clockwise moment will become ultimately greater than the clockwise moment, CW moment, and therefore the slab will topple and fall down. So slab will fall down. Fall down towards where? Towards the left. Alright. I hope this question should make sense. If you have any further doubts, you can ask me in the comment section. Let us come to the last question now. That's question number 6. Write down the names of the 3 man-made devices in everyday use that depends on their action upon the moment of the forces. Now this is a question you should be able to answer. There are so many examples that you can give here. The doors, the windows, the panels of the doors, they work on the principle of moments. A spanner, the turning effect of the spanner, the opening and the closing of the cap, a wheelbarrow, right? They all work on the principle of moments. So you can write your answers here. This is an easy question. Let us come to the second part. The figure here shows a uniform rod AB acted upon by 3 equal forces F. There are 3 forces acting on the rod. The rod is given to you, AB, 3 forces acting on it. State 2 reasons why the rod is not in equilibrium. 2 reasons when a system is in equilibrium, you know it. When the resultant force is 0, when the resultant moment is 0. Here they are talking about not equilibrium. Let us see the resultant force. Total downward forces. Downward force total is 2F. Sum of this and this. Total upward force is F. So the resultant force is not equal to 0. Similarly, resultant moment is not equal to 0. Why the resultant moment is not equal to 0? Let us take one point as the pivot. Let us take this point as the pivot, right? So how much is the anti-clockwise moment? Is there any force which is creating an anti-clockwise turning? If you look at this force, let us see each of the forces. There is this force which is creating a clockwise turning. There is another this force which is also creating a clockwise turning. Force number 1 is creating a clockwise turning. Force number 2 is also creating a clockwise turning. Force number 3 is not creating any turning because it is right at the pivot. Its distance from the pivot for force 3, I am naming the three forces as F1, F2 and 3. For force number 3, the distance is 0 from the pivot. So therefore, the moment created by the force 3 is 0. Force 3 is right at the pivot. It will not create any turning effect. So only clockwise and clockwise turning effects you are seeing here in this picture. There is no anti-clockwise turning which can cancel the clockwise turning. Only clockwise turning you see here, no anti-clockwise turning. You do not see any anti-clockwise turning which could possibly cancel the clockwise turning. So the resultant moment is not 0. Resultant moment is not 0 means there is a total moment here, some value of the total moment that you will get, which is same as saying that there is turning happening in this system. There is turning happening in this system. The system is not in equilibrium because the resultant moment is not 0. Let us come to the part B. Here it shows a uniform rod AB supported at its center. This is the center point, held at horizontal position. The length PQ is given to you. A force of 12 newtons is acting at a distance of 0.3 meters from the support. A spring S fixed at its lower end is attached to the rod at Q. Calculate the force exerted on PQ by the spring. So let us find the key term. It is held at a horizontal position. Held at a horizontal position means it is not turning. When would it not turn? When the anti-clockwise moment, let me write in short form, anti-clockwise moment is equal to clockwise moment. Then only it will held in horizontal position. So what is creating the anti-clockwise moment? The force 12 newtons multiplied by its distance 0.3. And what is creating the clockwise moment? It is the pulling force by the spring. This is your clockwise moment. So let us call this force as F. Multiplied by its distance, it will be 0.5. If this whole length is 1, half the length is 0.5. So how much is the value of F? You can substitute the values, you can solve the equation, and you will get the value of F as 7.2 newtons. That's your answer. Now let us come to the last question. Explain why it is not necessary to know the weight of PQ. Why is it not necessary to know the weight of PQ? So where would the weight act from? The weight will act from the center point. The weight will act from the center point like this. I am using a green color pen. The weight would act like this. And if you see that the weight is passing straight through the pivot. The weight is passing straight through the pivot. So the distance of the weight from the pivot is how much? Distance of the weight from the pivot is 0. So what is the moment created by the weight? Moment due to the weight W is force times distance. Force is how much? Weight times its distance, 0. Moment created is 0. Moment created by the weight is 0. So you need not use the term W, which is a force, in any one of your calculation for anti-clockwise or clockwise moment, because the weight W is not creating any anti-clockwise or clockwise moment. It is not creating any moment at all. You can ignore it. Why? Because it is passing through the pivot. So this is a very important tiny bit of concept that you should always remember. If a force is passing through the pivot, its moment can be ignored in your calculation. Why? Because its moment becomes 0. It is right on the pivot, its distance from the pivot is 0. It is not creating any moment. Moment is 0. You can ignore it, right? So therefore it is not necessary to know the weight of PQ, because the weight of PQ is not creating any moment. Fine, this was our set of videos on the worked examples for this chapter on moments, impulse and impact force. Please go through this theory. The theory talks in very good details about these concepts. If you go through the theory videos, you'll understand every tiny bit of technical details of the things that we have discussed in this video.